Hello, we are here for one more lesson of this AxisVM training course, and the topic for today will be the mesh. So we will see inside the mesh toolbar. Clicking in this mesh tab, so we get these options available that are related with the mesh generation for both line elements and domains. Besides, we have some mesh refinement functions and some checking of all of these things. The mesh is basically the basis for getting finite element analysis in any finite element software, and so AxisVM is not different. There are a couple of techniques, so we will go through these options, which I think they are not complex because in the end all of the main procedures and all of the main assumptions that we need to guarantee are more or less automatic. Let us do first some geometry, a simple one. I will leave out the line elements because they are important, but I think the examples for the domains are good enough. So a rectangle, couple of lines, and something like this, and now a rectangle with this kind of look. And I will create some domains, consider all the geometry. Okay, let us say one material, let us say whatever it is, it doesn't matter much. Thickness 100 mil, and we have a couple of domains with this shape. Now let us go then to mesh toolbar. So we have a couple of functions. This first one, it is to create mesh in line elements, so it's basic. We have a couple of functions. We can try to choose one of the elements. So we have this kind of parameters. So maximum size, or if we want to make a division into n elements, or if we have arcs, we have a parameter for creating a deviation from the arc, a value, a numeric value. Regarding the domains, which it is what I want to show you. So we click in this icon here. In this particular case, we will choose all the elements, so okay. And then we get this dialog box where we have a couple of parameters to define the creation of the mesh. So first, we can create from the geometry that was chosen, and we have some options to create this mesh. So we can do it with a triangular shape, with a quadrangular shape, or a kind of a mixed shape, which is this example here. Besides, we can also influence the mesh size, and this will also consider the geometry that is chosen. So it will have smaller elements or larger elements, and it will check the shapes and what is behind. Let us do these examples so that we can see the difference. We'll choose first this triangular shape. So I will leave all these things unchecked, and I will leave this standard size chosen. So, okay, it will create the shape, and as you can see, it will make the mesh with this look in triangles. Okay, let us go behind and do the same. Let us do the same, this time with a quadrangular shape, and you see that we have a much different appearance. Okay, the mesh type, it will obtain or can obtain slightly different results. I will recommend always, if possible, the quadrangular shape for a better quality of what is created. You see that it's more regular, and this will also influence a little what we can obtain. We can do also a mix, and let us see what happens. So we have areas that are regular and some points which are not so regular. Sorry. Basically, this rectangular domain, it's a little more irregular to make adaptation to the shape. But I think these three examples are able to show you the difference between all of these things. I will create also a couple of nodes, and now when I create the mesh, I will choose all the elements. I will create a rectangular shape. You see that the nodes are points where the program makes some things around it, some different elements around them. So this definitely influences what is around. When we create the mesh, and before we do it, I want to show you the dialog box. So we have this element size. We can choose a couple of options. For example, this fit mesh to loads, where we can give some parameters regarding, for example, if it exceeds the load intensity over the value specified. In this particular case, I don't have any loads, so, and you have a lot of parameters for these guys. We can adjust the mesh to column heads, and it will make this tuning, if we can do this, on columns. We can have also a definition for uniform mesh size, or we can do an adaptive mesh size, and we can have also some control about the smoothing of what we can obtain. So you can play a little about these parameters to see what it is possible to obtain changing these options. For the moment, I will leave this because the mesh here is created. I think the examples were clear and it's easy for you to play a little with the parameters. Then we have a couple of functions that we call mesh refinement, and we can do several things. The first one, it is called uniform, and will let you refine the selected mesh, where we can specify the maximum length of the element. So we can try. We will choose only some areas so that you can see the difference. And we had 0.5, so we are choosing now 0.2. So it will change in this particular case. It influence all the structure because the elements we choose are connected to others, and it influences everything or almost everything that is around. Then we have something called, for another refinement, something called bisection. And basically it will bisect the elements that we choose. We will choose again a couple of points, and as you can see, basically double or cut by half what we choose. Another option, it is something called node relative. So it will refine the mesh around the selected nodes. So I will choose, for example, these two nodes. And okay, again, 0.2, and you see that increase a little the refinement of the mesh around the nodes I've chosen. Finally, we have something called the edge relative. It is the same that we've done for the nodes, in this particular case for an edge. And again, you see that made a smaller definition of the geometry around the edge that we choose. Finally, we have a couple of functions. First, it is a checking. So it will make a check of the geometry to guarantee that everything it is okay. So there are no, as they say here, heavily distorted elements. So everything seems okay. And these functions here, we can delete all the domain meshes from the domains. And we can delete also all meshes of the model. So as you can see, all meshes or all the domains. And we go back. So these are the things that I had to show you about this creation of meshes inside Axis. Any questions or any support that you might need from our side, so let us know, and we will give you all the necessary support.